Assalamualaikum and welcome back to my YouTube channel. So yeah, I'm back with another video. And in this video, we're gonna learn about Pythagoras theorem. So now let me give you a small intro about Pythagoras theorem first. First of all, Pythagoras, a Greek philosopher and mathematician, discovered a simple but important relationship between the sides of a right angle triangle. He formulated this relationship in the form of a theorem called Pythagoras theorem. So after his name, there are various methods of proving this theorem. We shall prove it by using similar triangles, and we shall state and prove its converse also, and then apply it to solve different problems. So it is a very commonly used and very interesting theorem. It might be informative for you, but let's see. So first of all, here is a statement. Now let me give you a small concept of right angle triangle. First of all, I'm gonna draw a triangle like this is a triangle. Three sides, and this side, which is known as altitude, or it is also known as height. Okay, this is equal to 90-degree angle. This indicates box-like structure 90-degree angle, and the side opposite to 90-degree angle is known as hypotenuse. And the last one is base. Base, hypotenuse, and altitude. And we're gonna name these sides as A, B, C. This is not a part of a theorem. I'm just telling for your concept. A, B, C. Now let's read the statement, and this diagram is gonna helpful for you. In a right angle triangle, this is a right angle triangle which has a 90-degree side opposite to 90 is hypotenuse, and the other side is base. The square of the length of hypotenuse, its square is equal to the sum of the squares of lengths of other two sides. Mean it's saying that the length of hypotenuse, square of length of hypotenuse, square of length of hypotenuse. The hypotenuse is equal to sum of squares of lengths of other two sides. These are the other two, and we're going to take its square and then add a square plus b square. This is given in the statement, like hypotenuse is equal to the base, its base square plus altitude square. So this is our like given data, and now we're going to prove this by using a long theorem, which is so easy peasy. Okay, so first of all, there are steps for solving a theorem given to prove and construction. First of all, these are three given. Actually, these are not three. These are only one. Let me explain you how. This is a triangle. Here we've given three sides A, B, C, and this is the construction work. D, construction work. This is A, B, C, and X, Y, and this is H. So these two triangles, this one triangle and this is small triangle. One is large triangle and one is small triangle. Understood? Like we're gonna just take the opposite sides of these triangles. Like B is there and here it becomes there. This X, like this side, like C, H, and B. Sorry, it is, I think so, B. Yeah. Oh no. How cute. Okay. ABC, and this is the small triangle. This is one and this is second triangle. Okay. So hope you understood about this. Now we're gonna write our given data. So first of all, given. What is given? ABC is a right angle triangle. ABC is a right angle triangle. It's saying a right angle triangle. So ABC is a right angle triangle in which C measurement C is equal to 90-degree, and BCA, ACB, and ABC. Okay, about the given. So the the first line which I have underlined, you can see in a right angle triangle. So in given, we're gonna write about right angle triangle according to the statement, because this is the given section and this is the proof section. And then we are gonna do construction. So we're only gonna focus in this given. ACB is a right angle triangle. What we have given in a right angle triangle? ACB is a right angled triangle in which measurement C is equal to 90 degree. AB, I'm gonna show how. Okay, so wait patiently. PCA and measurement AC equals B. So let me show you how this is possible. Here I have written ACB is a right angle triangle, no doubt. ABC, BCA and ACB. Simple. Don't be confused, guys. You can solve this theorem. Given and to prove. So as I told you earlier in the video, the square of the length of hypotenuse is equal to the sum of squares of the lengths of the other sides, means sum of hypotenuse is equal to sum of the other two sides. As I told you earlier in the video very clearly, C squared is equal to A square and B square. So hope you remember that very clearly. Like C square is equal to A square plus B square. Hypotenuse is equal to base plus altitude square. Now we're gonna do our construction work. So in the construction area, we're gonna write. Let me first show you that what is being constructed in this triangle. So take a point on AC, like draw CD perpendicular from C on AB. This is the construction work, and let CDH, ADX and BDY, and draw line segment CD splits ABC. Like if you draw here this line, it splits triangle into two parts, 1 and 2, which are separately shown in the figures 2A and 2B. So let me write this all in our construction work. Like draw CD perpendicular from C on AB, which I explain you very clearly on measurement AB. Like you can see now, C is a line from this to the line AB, and let CD, you can see from here, because I am here not there, let CDH, ADX, BDY, and line segment CD splits into two triangles, this one and this one. These are the large and small, so which are clearly shown in the figure 2A and 2B. So now let's prove this theorem using statements and reason. Let me erase this first. Simply we are going to prove C square is equal to A square plus B square. Okay, I have erased this. Now in this question I think I should erase the statement also, yeah, because it's taking too much space and we don't have a large board, so we're gonna manage in this small board. This part I'm gonna also erase. Yeah. So we're gonna prove this theorem, and here I'm gonna write this proof. Statement and here we're gonna write reason. So first of all, you can see that we have three triangles, and we're gonna take this triangle correspondence to this triangle, and then this triangle correspondence this triangles, because these two triangles are derived from the first triangle. So in triangle ADC has a correspondence to triangle ACP. Which triangle I'm talking about? Yeah, ABC has a triangle correspondence to ACB. And we are talking about the first and to it. We're gonna take the correspondence of these two triangles in ADC and ACB. These two triangles. This is this one. This is that one. Okay. So this triangle has correspondence this triangle, and we are referring to which you better know. We are referred to figure. Refer to fig 2a and 1. 2a and 1. Because we are taking its correspondence. Now we are taking its correspondence, so we are gonna match the angles and the sides. Angle A is equal to angle A. Angle A is congruent to angle A. These are also common and self-congruent also. Okay. Then angle ADC is congruent to angle ACB. Angle ADC is congruent to angle ACB. These are the construction work, because in construction we have drawn a line C, so C is included, so obviously it is construction work, and it's also given. And ADC and ACB, angle D and angle C is equal to 90 degrees. So we are also gonna write that each angle is equal to 90 degree. Okay, my writing is quite rough, tough, but and angle C is congruent to angle B. Angle C is congruent to angle B, and these are complements of angle A. You better know what is complement. Okay, complements of angle A. Now it's proved that angle ADC is similar to triangle ACB. So I'm not talking about congruent, it's similar. So let me show you the difference between congruent and similar. This is a similar sign, and this is the congruent sign. Congruent, which is equals, and similar which is only similar. You should remember this main thing. And it shows congruency of three angles. So here we're gonna write the reason. Congruency of three angles. Okay, so it is proved. And now we're going to talk about the side, like ADC is similar to ACB. So x over b is equal to b over c. How? Let me show you. X over b is equal to b over c. X over b equal to b over c, because these two are only one triangle, not two. Or we can say that x is equal to b square over c, because b comes here and it becomes b, so divided by c. And the reason of that measures of corresponding sides of similar triangles are proportional, we're gonna write here. What's the reason that measures of corresponding sides of similar triangle are proportional. This is the reason. And x is equal to b square over c. It's our first. Now we're gonna prove the second one, and then we're gonna prove c square is equal to a square plus b square. So let me erase the theorem because we don't have any kind of place here. Hope you guys like my videos. So I have thank you so much for my 1,000 subscribers. I'm so happy. Now please make 2,000. Okay, thank you so much. Now we're gonna take correspondence again in triangle BDC has correspondence to triangle BCA. This triangle has correspondence to this triangle. First we took this and this, now we're taking this and this, okay? So BDC, BCA. First we're gonna prove that angle B is equal to angle B, means we are referring to fig 2B and 1. Angle B is congruent to angle B. These are common self-congruent. Now, angle BDC is congruent to angle BCA. We are talking about D and C. Angle BDC is congruent to BCA angles. These are construction work as well as given. And you can see that we are talking here about C. So C is equal to 90 degrees. So each angle is equal to 90 degrees. No, these also of 90 degrees. Now angle C has corresponding to angle A. These are complements of angle B. Now it is proved by taking three angles that triangle BDC is similar to triangle BCA. So it shows congruency of three angles. It's showing the congruency of three angles. So yeah, we're also gonna take sides like how we took this side. So we're gonna take YA is equal to A over C. It's not difficult, but you need to learn it. Or we can write Y is equal to A square by C. It's our second result. It's our first and it's our second result. So it is also showing that corresponding sides of similar triangles are congruent. What is corresponding sides? Are congruent, okay? Now we're gonna prove C square is equal to A square plus B square by using these two results. First, let me erase this and then we're gonna move to our final proof, final part of the proof, and then you're gonna make me thanks because I did a very great work. I am great. Love yourself. I'm loving myself so much. So, but y plus x is equal to c. How? We suppose supposition work here. Then a square y equals y plus c equals c. So y value is this and this is x value. A square divided by c plus x value उसकी क्या है b square by c, and this is c by 1 and 2. You can see that I've taken these two x and y values there, and then By taking its LCM, it's become a square plus b square is equal to c square because c moves to there and it's become c square, and then because we have multiplied both sides by c. So here it is. Both sides. We have multiplied both sides by c and it's our final results. C squared is equal to a squared plus b squared. So this is our final result, guys. Give a big clap to me because I have done a very great one. Hypotenuse is equal to other two sides which were asked. C squared is equal to a squared plus b squared. This was asked to prove and then we have proved it. So hope you like my video. Give a big thumbs up and a very happy new year to you all, and comment down below that what's your new resolution for this new year. So goodbye and have a safe day.